Welcome to another video in the TimCo Retail Manager course. This course focuses on real-world application development. Right now, we're working on building out our first section of work, which is the basic register. In this video, we're going to create our tables based off of our design. Now, if you're a Patreon supporter at the $5 per month level or higher, make sure you head over to get the latest source code. Either way, make sure you subscribe to this channel so you can follow along. Okay. Let's get started. All right, so here is the design where we left off. So on the left here, we have our tables. So these are the things that we'll be addressing shortly with our table design. Okay, so I'm gonna move this over so I can see it, but it'll be off the screen for you. And the reason why is because that way we have enough real estate in our Visual Studio so you can see the design. So if you want to follow along, take a screenshot from before, or if you're a Patreon subscriber, just take the image file I gave you. Okay, so we're going to jump right into the TRM data project and open up DBO and just start creating tables. Now, I will make a couple modifications. Some of them were planned, some of them were based upon discussions we've had this past week on YouTube about things you want to see changed or suggestions. So the first thing that was planned is the list that we came up with is a guideline. It's a rough kind of overview. These are the things we want. In this video, we're going to dive into the specifics of how that gets implemented. And what that means is that in our design, we input things like create date columns or ID columns. And those are kind of just more implementation details, not planning details. So that kind of was in there, but I didn't really communicate that well. So I apologize for that. But that's one of the things we're going to add. And the other thing is we're going to adjust the sales tax and how we deal with that based upon some conversations. You've had some good ideas that came up, and sort of make some modifications there. So make sure that if you have questions or thoughts, put them down in the comments below. And I read them over. I consider them. I don't take every suggestion, but I do try to at least consider it and think through the implications of the modification you're suggesting. All right, so let's create our first table. So right-click on tables, say new table. And we're going to call this table let's start with the user table. And it creates a ID field that's not null. It's a primary key. So that's great. The only thing that we are missing here is that it's identity. And what that does is that's what creates our auto-increment. And what that is we're going to start off with a value of 1 for the first record. The next record will be a value of 2. And it will do it automatically for us, which means we don't have to put any value in this ID column. Now, here's a question I get a lot from people. They say, the query I have isn't working. It's saying you can't insert a duplicate record in the ID column, or the ID column cannot be null. And what you've done here is you've forgotten to add the identity. So if you have just this, that's great. It will work. The only problem is it won't put a value in there for you. So you have to put a unique value in every time. You're responsible for making sure that it's not duplicated, that it's not null, and that's kind of on you. So that's not really a great idea. And it's just a mistake usually, but every once in a while people want to do that. But in general, just add that identity at the end, and it will allow you to auto-increment. You can also select the row, and then go to Properties, and then under Identity Specification, select Is Identity and set it to True, and then make sure it says 1 and 1. And what that is the identity increment amount and the identity seed. The seed is where you're starting from, and the increment amount is how much you go up each time. So you're starting at 1, that's the seed. And then every time you increment, you go by 1. So you could start at 5 and increment by 10. So it'd be 5, 15, 25, 35. I don't see any purpose of that. Start at 1, go up. Now, the other thing here to note, and why I find this a more valuable way of going about it versus a GUID or other things, is that the tables, when you have a primary key, this is your primary index. And so what happens is it's called clustered index. And so when it stores the records on disk, it stores them in order of your clustered index, which is your ID. So when you add a new record, it's going to put at the end because the next value is always higher than the previous value. If you use a GUID, which is a randomly generated string, it's going to have to figure out where to put that on disk, and it's going to have to move things down and put a new entry in the middle somewhere. And so that's a little slower to insert records. That's why I like the ID. Also, it's a whole lot easier to remember 1 or 18 or even 473, which are all valid IDs, versus trying to remember one GUID. So identifying a person is easier. Identifying a sales entry or anything is just easier if you use an ID. Now, the one exception for this is going to be our user ID, which is not this ID. Our user ID actually comes from our authentication database, and that user ID is a GUID. So just so you know. Okay, let's actually put that in here now. We could do a comma and just enter it here manually, or we could come up here and say user ID. Now, the only problem with this is by calling it user ID, it sounds kind of like it's a foreign key that points to the user table and the ID record. So let's call this auth user ID. That way you know it comes to the authentication system, not from the user table. So auth user ID. And let's set the data type to be nvarchar 128. And I'm saying 128 here because that's what the authentication system uses. And we're going to allow this to be nulls for now. Okay, so the authentication system, you open up databases and look at this one right here. This is what Entity Framework creates for us. And this is a database we're not going to really touch. We're going to let Entity Framework control it. But for every user, it creates these set of columns. And one of them is ID. And that's the primary key, and that's an nvarchar 128. I don't think a GUID ever gets that big, but I want to keep it the same size as what Entity Framework puts it at. That way I don't have a case where I'm accidentally truncating someday. So that's what we'll leave it at, as 128 nvarchar. We'll leave it at allow nulls because at this point, I'm debating. So there may be a case. I don't think there's a case for creating a record here when you don't have a record for the login system. So let's make it not null. The issue there is which record do you create first? Do you create the record in the Entity Framework controlled database where they actually create their username and password and then they fill out the rest of the information? Or do you create a record for them here and then later attach the ID that gets created in the Entity Framework system? I think we go the Entity Framework login system first with a register and then create this record and with the information from the Entity Framework systems. So I think this is okay to make it not null. All right. So those are the big question marks. So now we can just move on to first name, which will be an nvarchar. Let's leave it at 50. And last name, nvarchar 50 is fine. We're making these not null. And then email address. nvarchar. This will be a lot longer. Let's do 200 for now. But let's look at what Entity Framework has done for us. They say the email address is 256. So let's change that here. Notice no matter where I change it, it changes in every place. So it's a nice convenient way of setting this up. I create a create a date that is a date time 2. Now, if you don't know the difference between date time and date time 2, date time is a legacy. You want to use date time 2. It's more efficient and it's designed for whenever you can, essentially. It's the newer version of date time, but they couldn't step on the toes of the old date time, so they left it in place but made it legacy, and now date time 2 is the preferred method. I'm going to set this as not null. What I am going to do is, let's say get UTC date. I guess not equals. So get UTC date. There we go. So the default is get UTC date, which is going to be the date and time in UTC, which is essentially without time zone. It's not a local time. It is the Greenwich Mean Time, however you say it, but it's the like currently I'm in -4, I believe, with Eastern time. So that's not my local time. It's basically +4 of my local time, +4 hours. So the reason I want to do get UTC date is you can always convert UTC into local time. It's a whole lot harder if you don't know what time zone the time was created in to convert the other way. Also, if you have servers in the cloud, like in Azure, first of all, Azure forces everything to be UTC date. But if it didn't, if you have a load balancing situation where you have one server in the East Coast, one server in the West Coast, and you've been working in the East Coast, but it goes down so you go on the West Coast, well, now it's 3 hours difference for something that happens a minute later. And that's not ideal. This way, it's always a time that you can work with, no matter where you are in the world at the same time. Okay, so those are the fields I think we need, at least for now. And this is one of those things where we can make changes down the road if we say, you know what, we need this bit of data, or we need this set up a little bit differently, and that's okay. But this is our first attempt at it. And one of the things I've found valuable is to always make sure that you just don't get so caught up in the details and trying to plan everything out that you don't do anything. Put something down in code and make it better. Keep iterating it until you get it right. Instead of trying to get it right the very first time. I mean, try to, but don't get so caught up trying to get it right the first time that you don't ever actually write code. Okay, so we're going to hit save on this. And now our user table is designed. Now let's create our sale table. So new table. We'll call this our sale table. So this represents one particular sale, and then underneath it will be a lot of details of all the things that are purchased in this one purchase. Okay, so this is the overall, the higher level. Let's make this identity. And now we will say, we're going to go through a list. So let's actually start with the cashier ID. And this is actually going to refer to the unique identifier of the user who was doing the work. So that's the cashier ID, which actually, that raises a question that I want to wrestle through. I think what we're going to do is say nvar char 128. And if you haven't caught where I'm going here, I think what I'm going to do is come back to the user table. This is where this modification process comes in. I'm going to delete the ID. I think that's what I'm going to do. So I'm going to come down here and say that I'm going to cut this out and make this the primary key and delete the ID entirely. So the primary key is the auth user ID, which is what we get from, in fact, let's leave it as auth user ID. Or nope, let's make it user ID. Now I'm wrestling. Here's my thing. I'm going to call it ID. I'm not a huge fan of that just because of the fact that now we're calling something ID that is not an auto-increment integer. It's actually going to be an nvarchar 128. But at the same time, the primary key is always ID in the tables. And other things really like to have that consistent thing, that consistent ID as the primary key. So I think I'm going to leave it like that. I'm going to call it ID. Let's hope it doesn't break anything. I don't think it will. But now we can say user ID and we know what it is. Or in this case, I'm actually going to say for sale ID, cashier ID, even though it's pointing to the user table. And some people really like the idea of having this, so it's a table name and then the column name. So user ID. Or in this, if you want to refer to a sale, it'd be sale ID. I get that, but it doesn't always make for the best names. In this case, great, it's a user ID. What does that mean? Is it the purchaser? Is it the manager? Or is it the cashier? It could be any of those things. And so to be more clear, I'm going to call it cashier ID. So let's leave it that cashier ID. I thought I changed it to nvarchar, but must be didn't take. There we go. So we cashier ID, but it's going to refer back to this ID. And one of the reasons why I did this is kind of where it helps to have a bigger picture of what's going on, because I know that I'm going to be dealing with authentication in the API. And so the API can tell you who's logged in right now. When they make a call, we can say, okay, this person is logged in. In fact, if we go to the API right now, the data manager, go to controllers, in the home, nope. Where was it? Values controller? It was a values controller. Right here. So we get the user ID based upon who is logged in. Okay, so we've authorized this call, and so they have to be logged in order to get access to this GET method. So since they're logged in, we can request their ID. And that's that 128-bit column, which is just a GUID. And it's not 120, not bit, sorry, character. And it's not 128 characters, but that's the column. So this is what identifies the user everywhere. So we could every single time look up that ID and match it to the user ID, the auto-increment value, but that seems silly. And it seems like a whole lot of extra work when I already have an ID that is unique, that I can use everywhere, and that I know everywhere. So I use that as the value because it just makes everything simpler. Every query is simpler. Every call is simpler. So that's why I'm going to do that. And now in my sales, that's going to be that GUID. Now I'll know exactly who it is without having to go to the user table. Okay, long explanation for basically I made a change. Let's actually close all but this. Okay, so now we also need the sale date. That's again date time 2. Now you could do just date or just time. That is an option now in more modern versions of SQL. But in this case, it works better to have a date time. And in fact, for most things, date time is the preferred way of going. If you don't want the time or you don't want the date, you just ignore that portion of it and it's okay. But if you really want specificity, then yes, you could do date or time. But in this case, a sale doesn't just happen on a specific date. It happens on a specific date and time. So that should not be nullable. So that's sale date. Next we have, and this is where we're going to get into a little bit of what the comments are talking about. We're going to start with subtotal, which is of type money. And then we have tax, and we have total. We don't have shipping, so we'll leave that off. But one of the things that we discussed in the comments, which I think is a good point, was that different items have different taxable values. And those taxable values may change over time. For example, I was just reading recently, I found it quite interesting. I'm from America, but in England, they have VAT, which is kind of semi-equivalent to our sales tax in the US. It's a little different though. But there was this court case that went all the way, I believe, to like the Supreme Court level over Jaffa cakes and whether they were I forget the term, it was a basic cake or a luxury item, essentially is what it came down to. And based upon that, they had to determine, do they tax it or not, or apply VAT or not. And so it actually changed because the Supreme Court finally ruled that they were not taxable. So that may change later. So, and it changed a couple times going through the courts. So the ability to have tax at this level, which is the overall sale, is great because you see the overall how much tax you paid. But I think we need to have a more specific per sale item tax ID or tax line. That way we know how much we paid at this particular time in tax for this particular item. So this tax line right here, well, we are going to keep it because it's the overall tax paid. So we have these three lines so we don't have to calculate it over and over again. But we're going to break this up into the sale detail record and have tax for each line, whether or not a tax is applied and how much at that given time. So that's, I think, all for this table. So you have a sale date, so we don't need to have a create date here. We already have one. We don't need a create date for every record necessarily, but it's good for some records. Okay, so now let's get into the next one, which is sale detail. And again, we'll make this our identity. And we'll come down here. And first thing is sale ID. I think it does make sense here to reference the table name sale. Let's get an int, not null. We have our item we purchased, which we were calling sale or sales item. That was confusing, and someone in the comments really helped me out here and said, kind of like a dull moment, why don't you call it product? And I was like, yeah, that sounds good. So product ID, so this is the ID of the product you purchased. And then I'll again refer to the product table, which we don't have yet, but it will. Will not allow nulls. And then purchase price, which is money. And then we'll have tax for this specific line. That's the addition we have here. And that will again be money, and it'll be 0 if none is applied. In fact, we'll just put 0 there as our default. Okay. And after that, we also have our quantity. That'll be an int. And default be 1. Let's actually move quantity up. Come on. Here. We'll do it this way. Gonna move quantity up to after product ID because it makes kind of more sense in the flow of things. Even though you're not going to be technically reading this table directly, it still makes sense in the flow of things to say quantity first before purchase price and tax. Because our purchase price and our tax will be based upon the quantity. So if an item is $1 and we're buying 5 of them, the purchase price would be $5. And if the tax was 10%, then the tax would be 50 cents. Okay, we're not going to have separate columns for, $1 is the item cost and then quantity 5, therefore the total or subtotal was $5. The tax was, whatever, 10 cents per item, and then the, times 5 is 50 cents, and have all these different columns. They're basically just calculations. So I'm not even going to put a total here. I've debated a little bit. It is nice sometimes to not have to do the work of retotaling every time. And that's why in the overall sale record, it has the subtotal, the tax, and the total, because those we'll use a lot in reports. But in this case, I don't think we need to have it that often. And so I'm going to leave it not in place, essentially. If we ever decide to come back and modify this, what we do is we add the column for total and then just run a script that basically updates every total based upon the purchase price and the tax. Combine those two, that's the total. And at that point then, going forward, you can just make sure that you're doing that calculation yourself every time. But I'm going to leave it off because the other thing that scares me about calculations is they can get off. If you don't update it every single time we make modifications, then there could be a problem. And I don't want a discrepancy between my total and what adds up to that total. So let's just leave it off. All right, so there's the sales detail table. And now let's create the product table. Which was the sales item table when I had poorly named it. Identity. I'm not a huge fan of all caps, but it is kind of the format that SQL is written in. So instead of trying to fight that, I'll just be consistent with that. And that is something that you're going to have to work with over your career. When you get in an environment, you may find that their naming scheme or their casing scheme or whatever else isn't quite what you prefer. The goal here is not to just change everything they do. The goal is somewhat for you to conform. Now, you can definitely suggest, hey, you know what? I like this naming scheme or this formatting scheme because, and kind of lay it out, maybe even do a demo for them. And if they like it, maybe go ahead and start changing over to that. But the reality is in most cases, it's better to conform to what's there so that's consistent. Consistency beats partially good every day. So be consistent. All right, so product name. And this will be a nvarchar. I hate to make more than 50. Let's leave it at 50. If it's anything longer than 50, it gets really just long. But at the same time, 100 will cover it for sure. Or it should. Again, you never know. Description. And this one, I'm going to say nvarchar max, which this is a totally different animal. So you can do nvarchar 4000 is the largest number you can put in there, and that's 4,000 characters of Unicode, which allows for, basically every character, not just the American standard, basically. But if you want more than that, you use nvarchar max, which what it does is allows for a lot more books worth of text, just tons. But it stores it differently. So it actually stores it on disk differently, and it doesn't store it in the row essentially with the rest of your data. So there is, I believe, a little bit of a performance penalty when you do max, but and there is a storage issue when it comes to storing your data. But the reality is, this is not what's going to push you over the edge to too much data. So call it good, end of our char max. And you have to have some kind of description. Let's just leave it at that. And let's go with create date, which is date time 2. And again, get UTC date. So that every time we insert a record, insert, not modify, every time you insert a record, this will get appended by default with the UTC date. Now, let's last modified. I debate putting this in here, but I'm going to. So last modified is kind of useful in the fact that you can tell when's the last time you made a change to this record. So if a product changes over time, we'll see when the last update was and know, okay, well, if we had an issue with something before then, we know that the product name actually changed from then. So it can be useful in certain circumstances. The key here, though, is you have to update it manually. Now, I did put a default value of get UTC date, which is going to put the same date and time as the create date when the record gets created. However, it will not update whenever you modify a record here. So you have to manually modify it every single time you modify a record. That's just important to know. Otherwise, it looks like your record never changed, even though it's changed 5 times, because you never modified the last modified column. So just note that's there, and it can be useful for things like products, but it's not something you use everywhere, and you have to modify it manually. All right, that's all there really is to the product table. One last table for now is going to be the inventory table. Make it our identity. So this lets us know when we purchase things and how many we purchased them for and all that good information. So let's start with the product ID. That's an int. And then a quantity. So how many are we purchasing? And we're going to default that to 1. And let's put our purchase price here. That's how much we purchased this overall lot for. And then we're going to have purchase date, which is a date time 2, and get UTC date. We're going to assume that when we put the record in, that's when we purchase something. If we want to change that, that's fine. We can put a different purchase date in. So you can backdate it. You can put it in the future. That's fine. But by default, it's going to assume that you purchased it right when you entered this record. Now, the one thing I skipped over that we have in our design is the retail price. Because I think we want to modify where that retail price is located. I think instead, we want to put it into our product table. Let's actually put it after description. I'll put it right down below. And this should be money and not null. Let's make all caps. There we go. So now we have a retail price in here. And the reason why is because I think that it makes more sense that we set a retail price on an item once and then maybe make some tweaks to it, but that's, we set it there at the product level, not every time I make a purchase for our inventory, we have to reset the price. That kind of makes more sense to me to put it there. All right, so that's all of the tables that we had to lay out. And that's kind of the design process where we design something and then we kind of take a break from it. That's really helpful if you can take a break from it. Don't just do it right away if you can help it. We took a break from it. We thought things over. We had some new ideas and we came back in, took our design and used it as a basic guide, but didn't say we have to follow this exactly. We allowed for some flex in there. Okay. So that's a good way of going about building a system, is that you allow for that flex and allow for the growth of your ideas over time, because usually those ideas get better. When you put a base idea out there, it allows you to then iterate on that idea. And that's again why I say get something out there, build something. Because you put it in a code or you put it on paper, over time you're going to look at that and go, I could do this better. I could do this better. And you start making changes and it makes it even better. And you wouldn't have gotten that if you just had this idea in your head, because you don't see it, you don't feel it, you don't touch it. And that's what actually putting it in code or putting it on paper, those two actions really help you make those tweaks and modifications. So I like doing both because putting on paper is easy to change and it changes a lot initially. And then once you have it on paper the way you think you want it, which is what we did in our on OneNote, so we typed it all out. Once we have that idea, give it a little time and then go put it into code. Because that, as you saw, this process made those changes. We made some changes to the process or to our design because we had that benefit of some time, benefit of discussion. Okay? So very important to the process. Don't try and shortchange it by going right to typing, because you'll make more mistakes, you'll have more tweaks you have to make, and you'll miss stuff. Okay, so we have our tables. We can go ahead and publish this right away. So let's go ahead and double click this publish and say publish. It's going to publish to our local DB. And once we're done there, we can look at the TRM data. There's TRM data, tables, and now we have our tables here: inventory, product, sale, sale detail, and user table. One last thing to do, and I don't always show you this, but I'm going to this time, is I'm going to make sure that I select all of these, right click and say stage, and then create a commit for this. Let's call this register DB tables. The tables for the basic register system. That's good enough. And we'll commit staged, and we can go ahead and come over to sync. Make sure we do our fetch first, make sure there's nothing up there. I already did this before the lesson, but I just want to show it, and I can, since there is nothing, we can hit push. So that takes our latest changes, pushes them up to the server, and now we have a clean branch locally with no changes in it. Now, one thing you may notice is the red icon here that indicates that this is ignored. If you mouse over it, it says ignored. That's because publish scripts or publish XML documents are by default ignored, and that's a good thing because these may have usernames and passwords in them. This one doesn't, because we're saying it's a trusted local connection, but in general, these are not things you want to default to showing. So just know that doesn't go up. All right. In our next video, we're going to tackle the front end, the very front end, so a WPF login screen. So that's what's coming up next. And the reason we're going all the way to the front end instead of doing the API in the middle is because I want to get those screens designed and built, and then we'll start wiring them up. And once we have the screens built, we'll better see what needs to be connected and how we need those connections to be set up. So next is the login screen. After that, we'll move on to the other WPF screen and then work on the API as well. Okay? Thanks for watching. And as always, I am Tim Corey.